This recording will be made live tomorrow, and it will be on the discussion board as well as the competition. So please do share this with people who are going to be joining. Is there anyone that would like to unmute themselves and tell us where you're calling in from? Rodney, I see there's a Rodney in the chat. Do you want to let us know who you're where you're calling in from?
Hello.
Hi, Andrew.
Yes, so this is Andrew from Ghana.
Awesome. Welcome. And how long have you been competing in the challenge?
I haven't started yet, so I'm eager to learn what the competition is about from the webinar.
Brilliant. I'm so glad you're here with us.
Hello.
Hi, Rodney. Where are you calling in from?
Yes, hello guys. My name is Rodney Mawero. I'm calling from Nairobi, Kenya.
Amazing. Thank you so much for being here with us. Have you started the challenge yet?
Yes, I started it, then things became too difficult at some point.
Wow. So you must have tried a lot of things already.
Yeah.
Great. If anyone else would like to introduce yourself, please do so in the chat.
Hello.
We would love to connect with you. My name is Amy. I'm a data scientist at Zindi.
Hello.
And I'd like to officially welcome you to the IBM SkillsBuild Hydropower Climate Optimization Challenge. This is our webinar. The agenda for tonight is we're going to have an introduction by Dr. Zeeshan Shafiq from the University of Engineering and Technology in Peshawar from Pakistan. Next, we're going to have an introduction from Donia, the business change and learning professional at IBM. And then a very exciting, we've got our own Kojo from the leaderboard, otherwise known as Duke Kongo, who will be doing a starter notebook walkthrough for us. I'm sure you've seen his Cat Boost notebook on the leaderboard, or his cat notebook, so that will also be shared there. Dr. Shafiq, would you like to let me know when I can start playing your videos?
Yes, thank you very much. This is Dr. Zeeshan from UT Peshawar, and I'm excited to present our project, which was about deployment of our multi-user devices in the off-grid region. So just to give you a background, we started with the survey of the region, and then we implemented our devices there. And after that, we performed certain quality checks. That was to identify which of the readings are true positive, which are true negative, which are false positive, which are false negative. And there was a set criteria that I will explain later on. So yeah, Amy, go ahead and you can share the D1 video in which we have surveyed the region before implementing our products. Thank you very much, Amy, for putting on the video. As you can see, this is an off-grid region. Yeah, so you may start the video, and after that, I will explain.
Let me click play.
Thank you so much for playing the video, Amy. First of all, we surveyed this region. This region is an off-grid region which is called Kalam. This is a snowy region, and in extreme snow, people rely on burning the woods, which gives rise to global gases emissions, and which lead to climate change events such as floods. So to overcome and to monitor the electricity parameters, we deployed our system in this region, and we deployed it on all three levels. That is on consumer end, on transformer end, and at distribution end. So we deployed it on two sites. One was in Junglein Kalam and other was in Ashuran. Each site was having two generators, and we have deployed it upon around 26 transformers, covering around 525 users. So the readings that we got populated a very good data set, which gave us the insight how to map the energy consumption with climate change and with climate overall. So I guess you guys are having fun out there implementing the forecasting models, and we are looking forward to the winning team on this one. Amy, over to you.
Thank you so much, Dr. Shafiq. It's been an absolute pleasure working with you in the data and setting up this competition. I just want to ask if there's a Donia on this call and if she'd like to unmute herself. Okay, moving on with the schedule, I would really like to invite Duke Kongo to share his screen. Duke is otherwise known as Kojo. You've probably seen him on the leaderboard and the discussion forum. He won't be sharing his most up-to-date notebook, but he will be sharing his just better, or a lot better than starter notebook, and he'll be going through some of the intricacies of the challenge. If you have any questions, please put them in the chat. And after Duke's finished, I'll read them out and Duke can show you in the notebook what's going on. Duke, do you want to share your screen? Unmute yourself and share your screen.
Okay. Let me share my screen so that we get to see things. Share screen. Okay.
Can we have a thumbs up from the audience if you can see Duke's screen? Brilliant. I can see it, which means everyone can.
Okay. So this is just a simple starter notebook on the challenge, the hydro challenge, and it's basically having EDA, from EDA to the actual model building to the development itself. Then how you will be able to infer, then produce the results. So I'll go through it step by step. So actually, I'll not run everything because some of the code takes a bit long. So let me just start from the importation. Okay. And don't mind these errors. These are just errors that you can just go out with. When you just run the notebook itself, everything runs well. So the first thing you do in this notebook is you've imported the models. So we basically have pandas, NumPy, matplotlib, just for visualization and playing with the data. That's with the pandas and NumPy. Then we have scikit-learn, the metrics. So if you want to calculate the metric, the RMSE score at the end of it all. Then we have the sklearn model selection for cross-validation, which is basically separating the model into, separating the data set into two, a train and a test, so that you can evaluate whether your model is performing well before you infer. Then we have the models, CatBoost, LightGBM. But in this starter notebook, I only did it with CatBoost. So let's continue. So you load the data sets, which are just basically this. These are just passing errors, so you can just don't mind that. Okay. So we have the data sets load up here, and we can see we have date time, VRED, current, power factor, KWH, and the source with the other features. But there's something very strange about this competition. You will realize that this competition doesn't have a test set that you can infer to. So you use the sample submission that is given. So what do we then do? So let's try and separate the consumer devices over here. Yes, the source. So consumer device 10, data user 1. We are just trying to see how the data is structured so that we can understand it better. So we separate them. We just use the string extract function, or let me say method from Python to extract the consumer device and the data user. Then later on, you realize they said in the submission file, let me go down here. So in the sub file, right, this is how you're supposed to submit your work. And there's something strange about it. You're not submitting any other thing, but only the consumer device with its respective energy utilized. So the reason I did this was because where am I? Yeah, so the reason I separated it is because I wanted to find out how many devices are there, how many users are also there in that same place to understand the data more, because that's the main point in doing this competition. So we have the consumer device. These consumer devices, when you check through the data, you realize that they are not in the data sets. So you can decide to remove them, or you can use them for your analysis to make your model more robust. Okay, so we filtered the data set and realized that these data sets only has the dropped devices, but we are not going to use that. It was just to know the devices over there. Now let's start the actual work. Now we want to infer on this trained data set, but the test set doesn't have the other features like the V-red, the what do you even call the power factor, the current, the V yellow. It doesn't have any of those. So what do you have to do? It means those features should be, I won't say useless, but you can use them in another way to win this competition. But basically, we can do away with them and just go in a time series manner. So we have the all data DF, date time. You change it to a date time for pandas so that pandas can pass it well and read it well so that you can get what you want at the end of the day. Then we have to group them, okay, because it is basically per hour. Have you seen it? Or is it per 5 minutes? So if you watch it carefully, it's per 5 minutes for the data. And we don't want that. The competition is telling us that we should submit per hour and per day. Or am I even right? It's per hour, if I'm supposed to be correct. Let me check the data. Because we will have to aggregate it. Yes, so I think it's basically, let me check. Okay, so it's basically per the daily report. So we are checking per day. Sorry for that. It's per day. So what we are going to do is we are going to aggregate the data and the results over here in the train set. That is the energy utilized, such that we will have each day the amount of energy used. Great. So after we did that, we got some values over here, and it's just the head of the data frame. Now, when we do some plotting, you get to realize that from July to the end of it, that's around August to October. That is where you see a lot of readings. So in these dates, from the 6th of October, if I'm right, or am I right? No, from the 3rd of June. From the 3rd of June 2023 to 2024, that is July, all those values over there were basically zero. And you will see it over here. Wow, I didn't do this. I'm coming. Give me a minute. You realize that all the data sets from the beginning of the dates, which is the aggregated dates, 2023, 6, 3, 2024, 923, they all have values from 0. But around July to, would I say, September, close to, from around July close to September, you realize that the values over there increase. And basically, they are all above maybe 5, some are even close to 40. And that is for consumer 10. You can plot many of them to understand the data more. But basically, this is just a starter notebook to make us understand what the thing is all about. So we decided that, well, if that's the case, I will just take the minimum date, then the end date, find the frequency for all of the day, like the frequency is supposed to be the day, then we plot for all of them into the data set, and that's where you get this, our complete data set. So this whole, I won't say function, but this whole code block is basically to create the data set to pre-process the data set for model training. So this is our complete data set, the head of the data set. Great. Now, we will ask ourselves, okay, well, what can we do next? That's where feature engineering comes in. But mind you, there was another data set on the climate data, and we want to utilize it because, of course, climate would definitely affect it. Looking at snow and all those stuff, it definitely affects the results you get. So we decided that, okay, we add the climate, we find the mean for the temperature, the dew point temperature, we also find the mean, the wind, we find the mean, the total precipitation, we find the sum because you're looking at the rainfall, the number of rainfall. Then the sum cover, we find the mean. Okay. So we've basically reached the interesting part after we've pre-processed the data set. So we have the dates per day, the source, we have the consumer devices, the data users, well arranged. We also have the aggregated data. And in this notebook, you realize that I dropped all the 0 columns. So there is no 0 column there for the empty days without energy utilized, or the ones that are missing in the data set. I dropped all of them so that we will focus on only the days that have the energy utilization. Okay, so we move on to the data set. That's where we've reached. I tried lag features, so meaning I just took the previous results, placed it in the data set to try and get a better result. But funny enough, it didn't really work out. Or from this notebook, I might not be doing it well. So what I did was I started doing feature engineering. Of course, I separated it in consumer device, data user. Then I decided to create features for the years, the month, the day of week of year, a quarter of the year, and if it's a weekend. And it's quite simple over there. You can see if the days is 5, well, it should be 0, and if it's not, it's 1. It's just simple like that. So this is the actual data set that we have now. It's quite lofty, but it's great. So we have all the features we need. But now let's try and input it into the model. So I'll create our X variable and the Y variable, the X gets. And we decided to drop the source, the date, and the power utilized because, well, it's not something that we want to use. We want to predict not using it as not what we want from this competition. All right, so after removing all those features, we've gotten some beautiful columns over here, temperature, well, all the features that we need. Now, we split them into train and test sets. For the train and test set, in this notebook, we went through a simple train test split, which uses the random states. So instead for it to be using the normal time series data, okay, we use the last 30 days, the last 20 days, the last 15 days. We decided to go randomly. We take it randomly and let the model find everything out. But the interesting part of this is we stratified it on the consumer device. So on the consumer device, it's going to break, it's going to arrange the data such that each set, that's the train and the test plate, the train and the test, they have equal proportions from both of all consumer classes. All right, and we just use a random set of 42 because it's random. We just want to go on a random way. Then we decided to train our model. Yes, we trained on 10,000 iterations. It looks funny, but this can either cause overfitting, or maybe you might be overfitting on the public board, but not per se the private. You might be overfitting on the public board, but you're not per se getting the right choice on the private board. That depends on the task you are doing. But when you try this, maybe training with more estimators, you are likely going to reach the bare minimum, so the bare minimum loss, so that you don't per se get a model that is underfitting. So we wanted to get a good result on the board. So basically, we found the iterations. The loss functions is the RMSC, because that's what we are using for the training and for even the evaluation. And we even have the best model, use the best model. So in case it surpasses 10,000, it shouldn't use the last iteration. It should use the best model at that point. And the early stopping is there to stop it if it's not actually bringing an improvement. So after 100 iterations, it should stop it if it's not getting any improvements. Then verbose is just to make it such that we can see 100, each iteration 100 times. So from 100, we move to 200, 300, 400, so that it doesn't become too much on the screen. Then we fit the model. So you have the X train, the Y train, evaluation sets. So the evaluation set is basically the sets that you're using to know whether the model is actually doing well or not. And the train is basically what you are training on. So the X train, Y train, and the evaluation set is the test sets, so the validation sets. So you can see from the model, it's doing quite well on the public board. I mean, I said the public board. It's doing quite well on the testing, on the training. It's having a score of 1.7 on validation, which is, well, it's great. But it might not be ideal in this place because it's clearly overfitting. Why do I say overfitting? Okay, it's having 1.7, meaning the loss, or the loss that you're getting from the model, right, is basically of a root mean squared error of 1.7, which is literally good. But on the test set, it might be that the model was overfitting to the train set instead of the test set. But no worries. What we are looking at is how to train the model to get a good score on the board, and it's quite okay. So we found these are just evaluations to see how the model is doing well, and we looked at the maximum number that the model gives, then the actual test set. So the test set was 119 for the actual one. That's the maximum number it gives, and the maximum in the train set, what the model predicts, gives 80.9, and that is quite good. That is all right. So now what do? Well, we infer. Now we take the submission file because that's what we want to submit. We don't want to submit the other devices that will not even give any score on the board. So we take the submission file, we extract the date from the consumer ID, basically that. Then after doing that, we found that we have to make the features especially look like the train sets, or the model might not run well. So it should have the same features, just that it should be on their own, like the test set terms. So for example, if for the test set, the date was 2021, 2024, that's 2024 July, on the test set, it's supposed to be around maybe 9, or that to be August area 2023, so that you understand that they are having the same feature, it's the same date feature, but they are both having different values due to their own circumstances or the time they are at which they are in. So we have the climate daily. We also do the climate data again. We merge it to the test set to also get a similar result. We also extract the consumer device and the data user. Then we get this data set. That's for the forecast head. But we are not done. We have to add the year feature, the date feature, the month feature, like how we did it to the train sets. So after doing that, then we now do our thing. We extract, we remove the columns that were no good, or that we didn't deem worthy, because the KWH, as I said, it will cause data leakage, and we don't want that. And we don't even have the KWH over here. It's only zeros in the submission file, which is not the ideal thing. So we remove that one and the date and the ID. Then we have this data set for the test set. Excuse me. So after having this, we input the dates. Oh, I've already done that. Now, if there is a null value, you don't want that. You can just put -1. Then we predict on it, and it gives us these predictions. So I also decided to find the max to see whether it's actually doing well, and 74 was great. So after we've done all these, we then say, okay, let's clip the model such that the prediction such that we don't have negative numbers, because it's weird to have a negative 0.01 energy utilization. That's really weird, and we don't want that. So we can decide to clip it. You can also decide to use an absolute value if you feel that will be better. That will also be very great. Then we forecast. We just place it into the data frame, the forecast data frame, and we get the submission file like what we wanted. Then you simply submit. So that's basically the whole presentation on the starter notebook. Thank you so much.
Duke, thank you so much for this recording. I'm going to ask you to stop sharing your screen as I invite Donia Koch from IBM to join us. While Donia's preparing, Duke, do you maybe want to read through the question on the discussion forum? And as soon as Donia's finished, it's back to you, Duke, to answer the question. Donia, are you there?
Hello, everyone. Good evening. I am here. Just a minute. Amy, can you please ensure that I'm able to share screen?
Yes, you are.
Okay, great. I'm just going to put the lights on. Just give me one moment.
Good call. If you're struggling with this challenge, then I really recommend listening to Donia and what she's going to share about the skills build, because what IBM's done is pretty amazing.
Hi, everyone. Good evening. I realized that it's getting into evening here. Some of you might be even later. So I've put the lights on. It's might be super bright now. But thank you so much, Amy. And hi, everyone. I'm here from the IBM SkillsBuild team. I understand that you are busy with a challenge that is pointing you to some of the content on SkillsBuild. So I'm just going to literally spend no more than 10 minutes to talk a little bit about what the IBM SkillsBuild platform is, and a little bit more about the learning. But as an introduction to myself, I'm part of the Middle East and Africa corporate social responsibility team, and my role is focused on skills build for Middle East and Africa, looking at creating great learning experiences and how best to customize our content, tailor our content, and align it to different programs like the one that we are doing with Zindi. I'm going to pull up my slides if you give me a moment. I see you have shared. Let me share the screen. So please confirm if you are able to see the window.
One second. There we go.
Okay, fantastic. That's great news. All right, everybody. So maybe if you can just write for me in the chat very quickly, it's for me to get an idea. Let me ask it as a question. So you can either just put yes or no or thumbs up or whatever is easier. have you already engaged with the SkillsBuild content through the Zindi platform? So basically the IBM content that is on Zindi Learn, have any of you already utilized that content or seen it? Because that will help me into how much I go in depth. If anyone has, if you can put yes, or maybe some no's as well, then I know a bit, okay. Okay. Okay, only getting a little bit of in-house biased. Okay, so I'm going to assume it's no. So then let me tell you a bit about, let me start right at the beginning about corporate social responsibility. So as IBM SkillsBuild, we have a big commitment, and this is our driver for why we're doing this work, is that we would like aiming to skill 30 million people by 2030. That's digital upskilling for specifically for underrepresented communities. And we have a specific target on artificial intelligence. As you know, that is in big demand right now. So we've got a closer target for 2 million learners by 2026. I'm sharing this with you because it's always important to have a vision for why we're doing it, and so that you understand what's behind our content as well. So how we plan to do this digital upskilling, one of our main ways is through the IBM Skills platform, which is all about powering and empowering yourself, let me be more direct, your future in technology, and through using different content that we've got to gain the skills that are aligned to different job roles. And as this is a CSR initiative, it is for free. So there's no membership to join or anything like that. We are working with different organizations, different partnerships, such as the one we have with Zindi, so that people can have opportunity for the upskilling. All right, so let's narrow it a little bit closer. So I said that IBM SkillsBuild is our avenue for the digital upskilling. In essence, it is a platform. It is a learning platform, and we cover a population, or let me say an audience, starting from high school content, adult learners, which is the majority of our group, such as yourself, going into academia. And a lot of our content is focused on technology. We call it technology hot skills. Of course, IBM is a technology company, but very shortly, I'll tell you a bit more of layering about what the content focus is. So you'll see on the right-hand side, there's some nice icons to tell you, but in essence, we've got a lot of courses. It's over 1,000 courses. I've mentioned that they are for free. We work with different organizations, different partnerships, and as it's linked to our CSR, we've got a volunteering footprint where a lot of local IBMers will volunteer their time. Some technical experts and consultants will volunteer. So we really try to keep it more on a CSR initiative kind of basis. So it's not a monetary kind of offering. And the one big focus I want to highlight here is the opportunity to have digital credentials, which I'll spend a minute on as we get down the line. All right. Since I don't think I saw any answers in the chat, could I at least get a thumbs up if you're all with me? Just your emoticons that are there. Let's see. I think I saw something pop up in the chat.
Yes, Augustine is currently working on the data analysis learning path. So we're very impressed with him.
Wonderful. That's really good. It's always encouraging when there's people utilizing the content and we get some feedback. All right, so let's go into the content focus. One thing I do want to highlight is I spoke a lot about technology skills, but really what our differentiating factor is that we want to create a holistic offering and a holistic employee. So we look at let's first say career management skills, which is more about how to get a job. So that's assistance with things like how to create a CV, how to have digital presence, digital imminence, for example, using social media platforms to optimize your resume. And then once you are in the job, we call it employability skills, which is around how to work to be effective in the workplace, such as problem-solving skills, how to communicate, how to do presentations like I'm doing today. And that's all the kind of skills that you need beyond the technology skills. These are the skills that will differentiate you from someone that's next to you that might have done the same course and get the same certificates. We're finding that the soft skills and the, we call them life skills, are the differentiating factors. So we don't only look at the content, although technology is the core, and we also look at, we focus more on a skills-based education. So it's not just about using one tool, for example, although there will be references to tools. It's about gaining core skills that will be transferable across employers and across different technology fields. All right, so as I said, I'm not going to go too heavily into this. This is my passion area. I just wanted to give you guys a little peek into what the SkillsBuild content is all about. So let's get it a little bit closer to home. We have got a collaboration, a fairly new partnership with Zindi. And Zindi has been very specific. As I mentioned, there's 1,000 courses. So Zindi has selected courses that are at the moment a mix between technology and the ones that you see in the block that's a bit teal are more the soft skills. So Zindi is slowly adding more courses, but these are the initial selected ones. And the ones that are highlighted in the blue blocks being artificial intelligence fundamentals, data fundamentals, and applied data with Python are the courses that have been recommended for the specific competition. Amy, I don't know if you want to add anything just on those, in relation to the competition. I apologize, I wasn't here right at the start, so I'm not sure if that connection has already been made.
So if you are new to data science or you're just trying to figure out Python, and especially those visualizations that Duke showed, these would be great places to start. Duke touched on lightly a bit about training machine learning models. What is a test and train split? Why do you need to do that? And that is covered in this artificial intelligence fundamentals. Back to you, Donia.
Thank you, Amy, because that was a perfect segue to exactly what I was going to show next. You don't have to read everything here, but this is really just a snapshot of what the artificial intelligence fundamentals courses, as in one of the selections, is about. So this is a deep dive only in artificial intelligence. So it's 10 hours. On that, you could see the courses listed there at the bottom left, but basically it goes all the way from an introduction to AI, and then it moves into different deeper AI topics such as natural language processing, using what's machine learning versus deep learning, and starting to use a bit of tools to run some models. But what I really, really like is that it actually ends with how AI can be applied in the workspace. And this is where I say it's more holistic and more looking at the skills that you can gain as well as the application of the skills. So this is a deep dive course. I'm emphasizing that because some of our programs, which Zindi hasn't specifically put on the platform, but some of them will have awareness across different technologies. The ones Zindi have selected are deep dive into specific domains. So similarly, we've got data fundamentals, similar concepts. It's 7 hours. So most of the fundamentals are 7 to 12 hours. That goes into from introduction to data concepts into some more of the tools, how to clean data, refine the data, what are the different languages, and then it ends with the application in the job space as well. What is very important to highlight is you've seen these two little pinkish red blocks. Those are the digital credentials that you will achieve after completing these programs. I believe you are quite familiar with digital credentials. I believe that Zindi also has an integration with Credly. So the concept shouldn't be too new. Thank you for that confirmation, Amy. But just in a summary, I'll let you know that I think if I had to pick one of my favorite words when I heard about or learned about credentials is the word of portability. So it's like carrying your portable certificates. If you can imagine in the old days, then people might have had like a briefcase or a file with all of the credentials in. Now these are badges, online portable badges that are they are vetted through organizations such as Credly that are linked to specific sets of skills, and they are a way of proving that you have gained those skills. So it's not the same as a completion certificate, because this is really, say, going through like a little assessment, for example, going through the program is saying that I now have the skills, not just that I have completed a learning. So I really encourage you to complete the programs and gain your digital credentials, because this is how you will, instead of sitting in an interview one day and saying, I learned about data, you've actually got your credential to back you up. So I hope this has given you a good highlight. I did promise that I will keep it within 10 minutes. I just want to end with one of our learners from Nigeria, who's actually a data analyst, and some feedback that he's provided. And I will maybe take a question or two if there are any. But thank you very much, everybody. I hope this has given you some idea about the IBM SkillsBuild content that is on Zindi, the Zindi Learn platform. So just to emphasize, I'll go back to here where you see that they are accessed through the Zindi Learn platform. There are instructions and guidance on how to sign up. And then each module is listed individually once you select which course you want to take. Thank you so much, Amy. I hope this was helpful, everybody. I wish you all the best with the challenge. I think there's 10 days left of what I saw today. And thank you for the opportunity to tell you about our program today. Thank you, Amy.
Thank you so much for being here, Donia. And we've had some really nice conversations in the chat, and some users are really enjoying the Credly badges and the learning paths. So thank you for IBM's partnership. And I'm so glad that you get to see some real impact here tonight.
Yes.
I'm going to invite Duke back to the stage. Duke, do you want to unmute and turn your camera on? I'm going to read out some of the questions from the discussion or from the chat over here, and then we would love to hear your answers. So the first question is, why did you remove voltage red, blue, yellow, and power factor? Have you tried involving them in your model? They don't have to be forecasted, but they could be important to differentiate between types of users. You don't have to give all your answers and secret sources away, but any insight here would be interesting.
All right. So yes, what he's saying is, and what the person is saying, it's actually true. You could definitely do a monophase feature, taking both sides. So is the house a monophase or not? Then that can be a feature. Then you can use to train it. But for you placing it as a feature, you're going to infer on it. Basically, there's a formula for current and all those stuff. When you calculate it, you realize that it's actually the same as the energy. It's just rounded up. But how would you be able to find it on the test set? That's the problem. So that's the reason why, if we didn't want to waste time, we just removed those features, the V red, V blue, and the V yellow, so that we can just go in a time series manner and train. I hope I'm making sense here.
That's brilliant. If you've got any further questions, whoever asked the question, please do comment in the in the chat here, and I'll read it out for you. I believe this is a question for me and Dr. Shafiq. Are the NAND values in V red, V blue as a result of power failures or failures of devices? That is a bit of and or. I believe that the devices were robust, but there could have been internet lags during that time where these are IoT devices, or it could have been that the power plant was down, as Dr. Shafiq mentioned, due to weather conditions, which Duke managed to pull into his model to determine that. So that's definitely something to take in consideration. Duke, do you want to take on the question about why don't we do a normal train test split here? Why do we do a different type of train test split, and how does this relate to forecasting instead of classic prediction?
All right. So, let me go back to that. I can make it a bit clear. So basically, what we do in this competition, if you go the forecast way, okay, and you don't consider some particular things, as in the zero factor, which I'll show you in the notebook soon. I hope everybody can see my screen. Can everyone see my
Yes.
screen? Okay, so I'll show you more about it. So this is the reason at which we use the random split was because of the fact that there are so many zero values from I think the beginning of the data set close to the end. So this is a very typical example. You can see the power consumption for consumer device 12. There is nothing here from December, January, February, up to July. And you can now see that there is some kind of power consumption. Then when we come here to the same thing, you realize that only in December that there was something, but from January to in the middle of July, there is actually no power utilization, no energy was utilized, which is quite weird. But when you look at the data, the climate data, it makes sense because at that point in time, generally, you can see from here the temperatures were quite low, and also a minute so that I can actually explain it better. Yes, and also in yeah. Excuse me, I want to show that discussion link that somebody was able to give out to make more sense to choosing that. Okay, so when you look at this discussion, it will be shared in the notebook too. You see that the guy was able to explain why those values were there, the zero values, and of maybe the lack of any measurement for the energy after the winter. Then he gave out graphs, a lot of graphs, which is very beautiful. Then also explained more about the springtime and all those stuffs. So we chose the random splits, right? Because if you are going with the forecasting way and you are using maybe you are using gradient boosting, okay, the gradient boosting model, it's likely going to overfit to zero, which is not what you want. And I'm sure a lot of competitors have tried that and they've realized they got 11, 13, 12 on the public leaderboard, and that alone is not even moving at all. However, there are more tricks in winning this competition. The first thing I can say is you can test a lot of models, not per se gradient boosting. ARIMA, for example, is another model that is very good, a statistical model that is very good because it doesn't look at the fact that we have to now, do some data partitions and stuff so that we know whether you're doing it well or not. No. What it does is it uses some variables, the PQD, then be able to get the value for you. And relatively, it can give you a score less than 7.5, 7.4 if you only model the thing well. It's more about data analysis. So this competition is not basically centered on the model itself, but how you feature engineer, how you play with the data set.
Great, thank you for that, Duke. We've got a question from Raphael Zimmerman. There are zeros interspersed in the 5-minute data, followed by normal values at part of this lag that Amy mentioned. Can they be treated as nulls or imputed? So I would like you to, I don't know the answer to this. This is something that you would need to decide on yourself. I personally would fill them in with the previous or following value, so back or forward fill. But because in the test set, this is taken over an average, so it could assist with the average. But that is my personal take on it. Maybe Duke's got something else he'd like to add.
Well, that one is also the same as what you are saying, Amy. Basically, that's how you approach it. That would be on you, because sometimes you might do it that way and you might get a better score, or it might not go well for you, depending on how you do it. So it's basically on you.
Yeah, domain knowledge, but also luck of the draw seems to be what's going on here. We've got 3 minutes left. Does anyone want to unmute themselves and ask a question live? A question from Atabek. Should we assume the power supply is constant during the test period? You can't assume anything because this is a real life situation. So make assumptions at your own risk. I would rely heavily on the climate data. However, I haven't built a model as far as you have. So take that into consideration as well. Just to repeat, this recording will be up tomorrow. So yeah, looking forward to seeing everyone slowly start moving up that leaderboard. And thank you to everyone who participated in the IBM SkillsBuild courses. I really recommend going and doing them. They're interesting. I found them interesting even as a data scientist with 6 years of experience. I'm going to stop the recording now. I'd like to thank Dr. Shafiq, Donia Koch from IBM, and Duke Kongo, Kojo, our very own Zindian, for his brilliant notebook. So thank you to everyone. I'm going to stop the recording now.